Good. So less storage and more runoff. So if you look at the chart, you see for the same type of this thing, the curve number increases as you go from A to D. So why is that so? Because the curve number is inversely proportional to the storage. If curve number increases, the storage decreases. So this means A will have low high, curve number will be low, and this guy's curve number will be high, which can be seen in the handout basically. See, as you go from A to D, the curve number increases. So okay. And also there's one more factor that depends on this, is called the antecedent moisture condition. All these charts are based on antecedent moisture condition type 2. All these charts. So if you get a antecedent moisture condition of soil of type 1 or type 3, there's one to convert. You have to convert it. Okay, all the curve numbers are given as AMC. See, it's given it out for both, or for cover conditions of AMC type 2. So if even the question is given AMC type 1 or AMC type 3, you have to convert it using these equations. Let's try the right one. Yeah, that's the right one. So so what is AMC? It's basically the antecedent moisture condition, which means what was the moisture condition in the soil prior to rainfall. How much was the moisture in the soil before the rainfall started? So if it had a high moisture content before the rainfall started, then the runoff will be higher because initial abstraction will be low. If the moisture content was low, it will, whenever it starts raining, it will absorb more rain from the more rain and store it inside him. So that's why the runoff will be lower. But if the moisture condition was higher, if the initially the soil had a lot of moisture, there will be less absorption of water, due to which the runoff will be higher. So that's what it's basically what it says. If AMC is high, storage low, and runoff high. Okay, and that's all. If you see in the equation, yeah, point is numerator, denominator. CN will be higher. Okay, right. Okay, so if we got this, let's try solving. Use these equations to solve for antecedent moisture conditions, or CN. If the AMC is 1, then CN1 becomes for AMC, for antecedent AMC1, the CN, the curve number equation will be 4.2 of the CN2 that we get from a table, divided by 10 minus 0.058 CN2. For antecedent moisture condition type 3, CN, which is called CN3, is equal to 23 CN2 divided by 10 plus 0.13 CN2. Okay, so using these equations, let's solve this problem. Okay, go to page number 129 and try solving the question without looking at the solution, obviously. First, try to solve it by yourself, and then we can have 10 minutes, and then we'll solve it together. So it has the, it's asking you to estimate the curve number and the effective, the depth of direct runoff, which is the runoff, which is R, and direct runoff volume. So you multiply R by the area to get the total runoff volume. And the total depth of precipitation is given as 127 millimeter. And the area of the this thing is 400 hectares. And also the soil group is C, and it's 50% detached houses with 0.1 hectare lots, 10% townhouses, 25% schools, and 15% open space. The antecedent moisture condition is AMC3. So try solving this question. You can have 10 minutes and then I'll solve it with you. Since there are multiple different percentage of area, you have to take the weighted mean, okay? The weighted CN, the average CN, basically multiply the CN of each type of land use with the area.